Hi, so we started talking about the derivatives, slopes, and we also talked about how to find the places where the hill will be having its maximum height locally and its minimum height locally. Okay, and then we said we would be interested in finding out the derivative of product of functions and such things. Okay, just to tell you what is in the store in the subject. Okay, imagine I have this ball. Okay, and I hang it with a thread and pull it like this and let it go. Okay, so you know what it will do. Okay, the kind of mathematics which we are learning, we are building up, will let us write down the equations which govern the motion of this. Okay, so at some point of time, we will, not now or not very soon, but we will be writing equations which describe the motion of the system. We will solve it, and then you will see the full force of calculus in action when you try to solve such a thing. Okay, so yeah, that's the plan. Let's get started. Okay, so where were we? Yeah, we were here. So these were the kind of things we wanted to ask, like this is what I was saying in the last video. Okay, very good. So before I go further, let me introduce a notation for a derivative which is very useful and popular. It's called Leibniz, Leibniz notation. Okay, so here the notation is as follows. Let me tell you the logic. Recall your f prime of x is f x plus h, or let's call it delta x, minus f of x over, this is delta x. Okay, delta x limit delta x going to 0. So if the value is f x at x and it changes to fx plus delta x when you go from x to x plus delta x, okay, so your function has value this thing here, which is this, and this much here, which is this, and the difference between these two is the amount by which the function has changed. So delta f is what? X plus delta x minus f of x. Okay, so this is really f prime of x is delta f over delta x limit delta x going to 0. Okay, and Leibniz introduced a notation where instead of writing f prime of x, he chose to write df over dx. Okay, so he was imagining this as a differential element df or differential element dx. Okay, but it's not really a ratio of these two quantities. It makes no sense. Okay, so you should not interpret it as a ratio of these two such things. The real meaning is this. Okay, but this is quite useful notation. Unless you lose sight of what it really means, everything is good, and we are going to also use this most of the time. Okay, so we are going to write df over dx. It's also called df dx, but I will call it df over dx or df by dx. You can also write this as df of x over dx. These are all same, and sometimes people also write as d over dx f of x. So d over dx acting on this. Okay, there are different ways of writing this, but always remember this is what the derivative is. Unless you lose sight of it, everything is fine. Okay, so I'll use these notations as well. So last time we were saying that we would be interested in knowing, for example, derivatives of let's say f is sine of x. So I want to know what is d sine of x over dx? We also said we would be interested in knowing what, for example, d sine of 2x over dx would be. Okay. Also we said if you are given a function f and another one is g, what is d over dx of this? Okay. These are the things we want to talk about today. Okay. Something very simple. How about this? Let's say I'm given a function f of x times some constant c. Okay. What's the derivative of this? It's trivial. Let me find out. d c times of f(x) over dx. This is what I want to know, what this is. Okay. So let's apply our definition of derivative to this. It is, I think I have done this already, maybe not. Okay, let's see. So I should take the function at some x plus h. Your function is c times f. Okay, so your f, the function at x plus h would be this. Then minus the function at x, which is this. And then I should take h divided by h and limit h goes to 0. Okay. Since c is a constant, and you know when you're taking the limits, a constant will come out. So you can write this as c times limit h going to 0, which is c times df over dx. Okay. So I have proved that d over dx of c times f of x is c times df over dx. That's the first thing we have proved today. Let's go. Okay, what should I do? Okay, let me do this. Let me talk about this. If I have function f of x plus g of x, let's say this is what h is. Okay. How about the derivative of this? The exercise for you. I'm not going to do this. It's fairly trivial. So please do this. All you need to do is use the definition of a derivative. Okay. And arrive at the following. Show that dh of x over dx would be okay. This one you show. I will show a proof of slightly marginally more complicated one. And also, if this were a minus sign here, instead of f plus g, f minus g, you would get this. Let's look at this. How about taking this? Okay. So I'm going to take the derivative of this product. Yeah. That will be your h prime of x is this. Limit h going to 0. So first I should take this function, which is h, and evaluate at x plus h. And then subtract this, divide over h, and take that limit. Okay. Let's look at the numerator. Numerator is this: f x plus h, g x plus h. Then you have this term. I'm going to add and subtract the same thing so that I add 0, and I want to add the following. Let me subtract from this f of x g x plus h. I add it back. I add the same thing back so that I have added 0 because those two will cancel. Okay, so these two cancel, so I have done really nothing, and then I should put this one also. Do you see why I have done this arrangement? Okay, see what I have done is I have put this factor same here so that I can take this common, and then this fx plus h minus fx and this divided by h will make you the derivative of f. That's what the logic I am following. Okay, so numerator becomes f x plus h minus f of x gx plus h plus f of x. I can take common from this and you get gx plus h minus gx, right? Divide by the denominator, which is h. So I have a h here, h here. Take the limit, h going to 0. What is that? Let's look at this piece. See, this is 0 by 0 form. H goes to 0. F of x plus h minus fx will also go to 0. Because when h goes to 0, this is becoming f of x. Okay, so this minus this is 0. And this is 0. So this is 0 by 0 form. And which is what a derivative is. Limit of this piece's derivative. And if you are worried about what gx plus h is, that's trivial. Remember, limit of two functions, limit of product of two functions is the product of the limits. So I can take the limit of this piece times the limit of that piece, right? Recall what you learned about the limits. But there is nothing special about this. When h goes to 0, it just goes to g of x. So I can write this as, and this piece is just the derivative. So I will write this as df over dx times g of x plus the same logic here. This is anyway f of x and this is dg over dx. Okay, so I have derived the following. D over dx of fx times gx is f times dg over dx plus g times df over dx. Sorry, it's the same. Yeah, it's correct. Or if you wish, you can write, yeah, it's, or another way, whichever way you like, f dg over dx plus df over dx times g. So you take the derivative, you leave this one untouched, take the derivative of this, which is this term, plus take the derivative of this, leave this one untouched. Okay. 7. Okay, this is nice. Now we will continue further, maybe in the next video, and ask what do we get for this. Okay, good.